In this section, we'll take a look at some important sets in the number system, such as the set of integers and the set of real numbers. Once we get the hang of these important sets, we can then use them in describing other sets that come our way. In mathematics, the set of positive integers consists of whole numbers starting from 1, 2, 3, all the way to positive infinity. We list it out like this and give it a shorthand of Z plus. The set of negative integers consists of whole numbers starting from -1, -2, -3, all the way down to negative infinity. We list it out like this and give it a shorthand of Z minus. The set of integers is the full suite of positive integers and negative integers, as well as the number 0 sitting right in the center. When listing it out, we start from negative infinity all the way to -3, -2, -1, then 0, followed by 1, 2, 3, all the way to positive infinity. We give it a shorthand of capital Z. There is also a special set of numbers called the natural numbers. It includes only the positive integers as well as the number 0. We give it a shorthand of capital N. The set of real numbers is a much larger set. It includes all the whole numbers we have discussed so far, as well as all the in-between numbers, such as the decimals and fractions. Is it possible to list out such a set? No, it will be impossible to do that. The in-between lines we have shown above do not paint the complete picture yet. It is actually a continuous spectrum of in-between numbers. So what do? Instead of listing, we do a description of the set. We say that the set of real numbers is the set of little x such that x is in between positive infinity and negative infinity. Note that this symbol that looks like a sideway 8 indicates infinity, and this set of real numbers is given the shorthand of capital R. Next, we split the set of real numbers into positive real numbers and negative real numbers. The set of positive real numbers, which are all the numbers on this side of the spectrum, is the set of little x such that x is more than 0 but less than the positive infinity. And we give it a shorthand of capital R plus. The set of negative real numbers, which are all the numbers on the other side of the spectrum, is the set of little x such that x is more than negative infinity but less than 0. And we give it a shorthand of capital R minus. Again, 0 sits snugly in between the two sets. Finally, we touch on a special set called the rational numbers. Rational numbers are numbers that can be represented as a fraction, such as 3 over 8, 4 over 3, or even 3 over 1, or 100 over 1. So it can include the in-between numbers as well as the whole numbers, as long as they can be represented by two integers, one over the other. To describe such a set, we say that the set of rational numbers is the set of little x such that x is written as m over n. And the conditions are that m must belong to the set of integers and n also belongs to the set of integers. And we give it a shorthand of capital Q. We've seen quite a few mathematical notations in the number system already. How about applying what we have learned and write a description of these sets? Let's begin with Z plus. Z means integer, or all the whole numbers. So Z plus means all the positive whole numbers. On the number line, we're talking about these numbers only. Previously, we listed out the set quite easily like this. But how can we describe the set? To do that, we can say that Z plus is the set of little x such that x belongs to this continuous spectrum on the right. So we say x is greater than 0. Also, we must pick up only the x's that are whole numbers. So we add another condition that x must belong to the set of integers z. Hence, the full description of Z plus is achieved by using two conditions put together. Next, we look at Z minus. Z means integer, or all the whole numbers. So Z minus means all the negative whole numbers. On the number line, we are talking about these numbers only. Previously, we listed out the set quite easily, like this. But how can we describe this set? To do that, we can say that Z minus is the set of little x such that x belongs to this continuous spectrum on the left. So we say x is less than 0. Oh, but wait, we need to pick up only the x's that are whole numbers. So we add another condition that x must belong to the set of integer. And there you have it. The full description of Z minus can be achieved by using two conditions put together. In summary, we learned to list out and/or describe some important sets in the number system. In particular, you need to know that capital Z is the set of integers. Capital N is the set of natural numbers. Capital R is the set of real numbers. And capital Q is the set of rational numbers. These are all sets that are commonly encountered in computing and math.